Today we're going to start with the first lesson on trigonometric ratios of acute angles. Trigonometry is the study of the measure of triangles, particularly right triangles. We're going to start with a review of primary trig ratios. Here we see a right angle triangle. This is a 90-degree angle. So this is the indication that this angle here is 90 degrees. And the labeling of the triangle is based on the angle, the acute angle that's being considered. So if you look at this triangle, the acute angle that's shown is this one here, which is labeled as theta. This is also an acute angle, but it's not labeled in this question. So we're going to use the acute angle that is labeled to determine the opposite and adjacent sides. So in relation to theta, opposite to theta is this side. So this is the opposite side. And in relation to this labeled acute angle, the side that's beside it is this side. So it is called the adjacent side. And the side that's opposite the 90-degree angle is called the hypotenuse. So it's very important to remember that the adjacent and opposite sides are labeled with respect to the acute angle that's being considered. And the hypotenuse, as always, is going to be the side that's opposite the 90-degree angle. We also want to remember what the trig ratios are. We have three trig ratios. We have the sine ratio, sine of theta. We have the cosine ratio or cosine of theta. And then we have the tan ratio or tan of theta. The sine of angle theta is the ratio of the length of its opposite side to the length of the hypotenuse. The cosine ratio of angle theta is the ratio of the length of the adjacent side to the length of the hypotenuse. And the tan of angle theta is the ratio of the length of the opposite side to the adjacent side. So in order to remember these ratios as a formula and memorize it, we have this a little box here, which is SOHCAHTOA, which means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So it's just a simple way to remember the ratios, three trigonometric ratios. Let's try an example. Find an angle to the nearest degree. So if you look, this is a right angle triangle, and they have given us a length of these two sides. This is the 90-degree angle, so obviously this is the hypotenuse. And in order to label opposite and adjacent sides, we have to look at the acute angle that is being considered in this question. Well, there's two acute angles. There's one here and there's one here, but this is the one that's labeled. So we're going to use this angle to label to determine what is opposite to it. So 4 is opposite to it, so this is the opposite side. And the 7 meters is adjacent to it, so this is the adjacent side. Since we're given the opposite and the adjacent sides, we are going to use the tan ratio, because the tan ratio relates opposite over adjacent. So since we have those two given to us in the question, we're going to use the tan of the angle given to us. The angle given to us is alpha, so tan of alpha is the ratio of the opposite side, which is 4, divided by the length of the adjacent side, which is 7. And we're going to take our calculator and determine what is 4 divided by 7. 4 divided by 7 is equal to points, very small numbers. So we're going to take it to 4 decimal places. We always take the trig ratios to 4 decimal places. So 0.5714. Okay, so that's to 4 decimal places. And then to find the angle alpha, we will use tan inverse of 0.5714. Okay, so we don't want tangent of alpha, we want the actual measure of alpha. So to find the measure of alpha, we have to do tan inverse. So when we use our calculator to find that, we get alpha is equal to 29.744, but always we take the angles to the nearest degree. So that is approximately 29.74 becomes, the nearest degree becomes 30 degrees. So that's our answer. We have another example here where we're given this is the acute angle that's being labeled. You can see that 29 is opposite the 90 degrees, so this is exactly this is the hypotenuse. Opposite to theta is 18, so that is the opposite side. And adjacent to theta is PQ, which is the adjacent side. In this question, we are given the length of the opposite and the hypotenuse. And from SOHCAHTOA, of the three trig ratios, the ratio that has opposite and hypotenuse in it is the sine ratio. So we're going to use the sine ratio for this question. Sine of theta is equal to the opposite side, 18, over the adjacent side, 29. So sine of theta is equal to, let's do 18 divided by 29 on our calculator and take our answer to 4 decimal places, 0.6207. And theta, which is what we want to solve for, is the sine inverse of 0.6207. So using our calculators, we'll find that sine inverse of that is 38.366, but we want to round our answer to the nearest degree, so this is theta is approximately 38 degrees, and that's our answer. We can also use trigonometry to find lengths of sides. So for example, we have triangle PQR, and we are given the measure of P, which is 25 degrees. We're given the length of PQ as 10 meters, and we are asked to solve for the length of the side QR, which is also labeled as X. So we can use trigonometry to find the length of this side. So let's label our triangle first. Opposite Q is the hypotenuse. Opposite 25, which is the acute angle, is X, so that is the opposite side. And adjacent to it is 10 meters, so that becomes the adjacent side. Looking at the three trig ratios, we can see that the ratio that relates these two sides, which is the X, which we have to solve for, and the 10, which is given to us in the question, opposite and adjacent, is the tan ratio. So we're going to use tan of 25 because we're given a problem where we have to find the length of the opposite side and we're given the length of the adjacent side. So the trig ratio that has opposite over adjacent is tan. So tan of 25 is opposite side, which is X, divided by adjacent side, which is 10. So if we solve solve for X, X is equal to 10 times tan of 25 degrees. And X is equal to 10 times, which is 4.66. We're going to round our answer to 1 decimal place. That's the meaning of the nearest tenth. So that's going to be 4.7. And in this case, it's meters because this is in 10 meters. So therefore, X is 4.7 meters. Let's try another question. We have a triangle LMN. This is the 90-degree angle, so that means X is the hypotenuse. And the 4 centimeters is adjacent to the 28 degrees, so this is the adjacent side. And this is the side opposite to 20 degrees. But the sides that are important for this question are the hypotenuse, or X, because that's the side we have to solve for, and the adjacent side because that is given to us. We do not have to bother with the opposite side because it's not asked or given to us in the question. So which ratio relates adjacent side and hypotenuse? It is the cosine ratio. So cosine of 28 degrees is equal to adjacent side over hypotenuse, which we have to determine, which is X. And in order to solve for X, we can cross multiply and get X times cosine of 28 degrees is equal to 4 times 1, which is 4. And if you divide both sides by cosine of 28 degrees, we get X is equal to 4 divided by cosine of 28. And to 1 decimal place, our answer is approximately 4.5 centimeters because this was given to us in centimeters. And that is the length of that missing side, X. We also want to recall angle of elevation and the angle of depression. So as you can see here in this question, if a person is standing and looking to the top of a building, then this angle, which is the angle between this horizontal line and his line of sight, is called the angle of elevation. It's also called the angle of inclination sometimes. And we have another angle, which is the angle of depression. So here you have a person that's looking down to a boat. He's standing on top of a cliff, and this is the imaginary horizontal line. So the angle between this imaginary horizontal line and his line of sight, which is this line, is called the angle of depression. And from Z pattern, we know that if this angle is 48 degrees, this angle is also 48 degrees. So we're just remembering and recalling the concepts that we have learned last year. So using that information, we're going to try to solve this word problem. You have two buildings that are 38.2 meters apart. From the top of the shorter building, the angle of elevation to the top of the taller building is 23.8, which is this angle here. And the angle of depression to the base of the taller building is 41.4 degrees, which is this angle here. Find the height of each building to the nearest tenth of a meter. So we have to solve for H2 and H1. So let's just consider this triangle because we can see these right angles here. So this is, let's label it A, B, and C, and let's call this D. So in triangle ABC, which is this triangle, which is a right angle triangle, we can see that tan of 23.8, which is the acute angle, this is the opposite side. Tan is opposite over adjacent, and this is the adjacent side, right? So this length from here to here, A is the opposite side, and the adjacent side is the length from here to here. Now, since we are trying to find the height of the building, I'm going to give another label for the length from A to B. I'm going to call it X. And I'm going to call the length from B to D Y, okay? So when I'm trying to find tan of 23.8, it's going to be opposite side, which is X, divided by adjacent side, which is the length from here to here, which is the same as 38.2 meters, which is the distance between the two buildings. So 38.2. And then when I cross multiply to solve for X, I get X equals 38.2 times tan of 23.8. And that works out to about 16.8 meters. So I got the length from A to B now as 16.8 meters. Oops, let me just go back. From A to B as 16.8 meters. Now I'm going to consider the second right angle triangle I have, which is triangle BCD. So in triangle BCD, tan of 41.4 degrees is again opposite side, which is Y, I labeled that Y, divided by adjacent side, which is again the distance from here to here, which is 38.2. So Y, when I cross multiply, I get Y is equal to 38.2 times tan of 41.4, and that works out to 33.7. Now both of these lengths are in meters because all the distances are in meters. So the height of the tall building, so therefore the height of the tall building will be X plus Y. If I add X and Y, I get the total length. So that's going to be 16.8 plus 33.7, which works out to 50.5 meters. And then the height of the taller building is just Y. So height of the shorter building is just 33.7 meters. So that is the answer to the question in the word problem. So up until here, we have been looking at grade 10 trigonometry. So we're going to start with what we are learning now in grade 11, which is reciprocal trig ratios. So we have three reciprocal trig ratios, which are also called the secondary trig ratios. Basically, they are reciprocals of the three ratios we already know. So they are cosecant, secant, and cotangent. So cosecant of an angle theta is simply the reciprocal of the sine ratio. It's 1 divided by sine theta. The secant of theta is the reciprocal of the cosine ratio. So secant theta is 1 over cos theta. And the cotangent, which is also called cot of angle theta, is the reciprocal of the tan ratio. So it is 1 divided by tan theta. If you were asked to evaluate to 4 decimal places the cot of 72 degrees, if you go to your calculator, you're not going to be able to see the secondary trig ratios on your calculator. And a scientific calculator will only give you sine, cosine, and tangent, which are the primary trig ratios. So how will we solve for the cot of 72? Remember, the cot of an angle is the reciprocal of the tan ratio. So to find this, what I'm going to do instead is I'm going to say that, well, if I want to find cot of 72, it's going to be the same as 1 divided by tan of 72 degrees. And that works out to 1 divided by 3.0777. And because they want the answer in 4 decimal places, it will be working out to 0.3249. Okay? Similarly, if I was to find the cosecant of 30, I cannot use my calculator, but I know that the cosecant of 30 is the reciprocal of the sine ratio. So this will be the same as 1 divided by sine of 30. And 1 divided by sine 30 on my calculator is 1 divided by 0.5, and that works out to 2. So that way I can get the answers indirectly by using the primary trig ratios. In this next example, we're asked to find all three reciprocal ratios for n. So n is one of the acute angles here. I'm just going to highlight the acute angle here, n. And they're saying find me the cosecant of n, find me the secant of n, and find me the cot of n, which are the three secondary or reciprocal ratios for n. So the cosecant of n, well, it is the reciprocal of sine. Sine is opposite side over the hypotenuse. So what is the opposite side? What is the hypotenuse? And what is the adjacent side with respect to n? Well, the side opposite 90, this is the hypotenuse. So I'm just going to label that. This is the hypotenuse. The side opposite to n, which is the 4 centimeters, is called the opposite side. And the side beside angle n, which is the 3 centimeters, is the adjacent side. It's always labeled before we go into the trig ratios. So since cosecant n is the reciprocal of the sine of n, and sine of n is opposite over hypotenuse, it means that the cosecant is hypotenuse over opposite, which is the reciprocal of sine. So it is the ratio of 5 over 4, because hypotenuse is 5 and the opposite side's length is 4. The secant of n is the reciprocal of the cos n ratio. And we know that cos of an angle is opposite side, adjacent side over hypotenuse. So the reciprocal will be hypotenuse over adjacent. So in this case, hypotenuse is 5 and adjacent is 3, so it's 5 divided by 3. The cot of n is 1 over tan of n. It's a reciprocal of tan. And tan we know is opposite over adjacent, so the reciprocal of that is adjacent over opposite, which will be 3 over 4. So there you have it, the three reciprocal ratios for angle n. Next example, we have to find the value of theta to the nearest degree, and we're given secant of theta is 1.7. We know that the secant is the reciprocal of the cos ratio, which means that the cos of theta will be equal to 1 divided by 1.7 because they are reciprocals. And then the reason I'm using cos is because I cannot use my calculator. It does not have secant on it. So I need to move from the secant to the cos to solve. So if I do cos of theta, every time you find a trig ratio, you take it to 4 decimal places. So on my calculator, 1 divided by 1.7 is 0.5882. Always take it to 4 decimal places. So theta is going to work out to be cosine inverse of 0.5882, which is to the nearest degree 54 degrees. I actually get 53.96 because all angles are given to the nearest degree, I rounded it to 54 degrees. Second example, cosecant of theta is 2.1685. I cannot find cosecant inverse and then use my calculator. So I'm going to find what is the trig ratio, that is the primary trig ratio that is related to cosecant. That is sine. So if cosecant of theta is this, that means that sine of theta is the reciprocal of 2.1685. So on my calculator, then I divide 1 divided by 2.1685, I get 0.4611. So my angle theta will be sine inverse of 0.4611. And then that works out to 24.46. I don't want decimals in my answers. So the nearest degree theta is 24 degrees. Okay. Example 6, determine the area of the triangle. So to find the area of triangle ABC, as we know, area of any triangle is base times height divided by 2. And this case, because this is 90 degrees, this is the base. And the height is this one, which is BC. So if I have the length of AB and BC, and I can then use the formula and find the area. But I do not have either of them. So I have base, which is AB, times height, which is BC, divided by 2, and I'll have the answer. I'm also given that this length, which is the hypotenuse, is 7 centimeters. And I'm also given cosecant of A is this number, 2.273. So I'm given these two pieces of information, and from these two pieces of information, I have to arrive at this area of a triangle. Or I have to somehow, from this two pieces of information, find the base and height, and then arrive at the area of the triangle. So as I can see here, because cosecant is given in terms of the acute angle A, that is the acute angle that is of interest in this question. And therefore, the side opposite A will be the opposite side, and the side adjacent to A will be the adjacent side, and this side is the hypotenuse. So I need to label opposite and adjacent so I can correctly use the trig ratios. If cosecant is this, that means sine of A is equal to 1 divided by 2.2703. So sine of A is equal to 0.4399, and that means that angle A is sine inverse of 0.4399, and angle A equals, to the nearest degree, 26 degrees. Okay, so I found that out. This is 26 degrees. So now that I have this angle and I have the side length, I can find the length of the base AB and the length of the height, which is BC. So I'm going to use now the sine ratio. Sine of 26 is equal to opposite side over hypotenuse, which is BC over 7. So my BC length is going to be 7 times sine 26. So BC works out to, I'm going to take it to 1 decimal place because usually sides are taken to 1 decimal place. So it's 3.1 centimeters. And then I'm going to use another trig ratio to find the length AB. So cosine of 26 is equal to adjacent side AB over hypotenuse, which is 7. And so AB equals 7 times cosine of 26 degrees, and AB equals 6.3 centimeters. So since I have AB and BC, I can now find the area of the triangle. It's going to be base, which is AB, which is we found out to be 6.3, times height, which is 3.1, divided by 2, and that works out to 1 decimal place, round the answer to 9.8 centimeters squared. That's the answer. Now you can try the homework questions.